Something really pivotal happened at CES 2026. It wasn't just another tech show. It was the moment robotics as we know it changed forever. We've moved way past the flashy demos. This is the dawn of the thinking machine.
And I'm not talking about just another product launch. No, this is a fundamental shift in what a robot even is and what it's capable of. You know that future that technologists have been dreaming about for decades? Well, it's here.
Look, we all remember those incredible viral videos of Atlas doing backflips and parkour. Super impressive, right? But let's be real, that was basically high-tech puppetry. The new Atlas is something else entirely. It's moving from those pre-programmed stunts to intelligent, adaptable work in the real world.
So, how did we get to this point? Well, it's really the convergence of three key elements. And let's start with the first one, the body. This is a physical form that's been perfected over more than a decade of relentless and, sometimes pretty wobbly development.
The journey of Atlas is just fascinating. It all kicked off back in 2013 with this kind of shaky DARPA-funded prototype. Fast forward to 2016 and boom, it's the parkour star we all saw in those viral videos. But the real game changer, that came in 2024 with a shift to a fully electric system. And now we have a production model built for the factory floor, not just a lab.
So what makes this new body so revolutionary? Well, for starters, it's fully electric, which means it's stronger, way quieter, and a lot more reliable. It's got an incredible 56 degrees of freedom, with joints that can rotate a full 360 degrees, which is way beyond human capability. It can lift over 100 pounds and, get this, it even swaps its own batteries to work nonstop. This is a machine built for scale.
But, a perfect body is just a puppet if there's no mind to control it. And that brings us to the next two parts of this revolution. The processing spine that lets it see, and the AI brain that lets it understand.
And this, right here, is the central challenge in all of robotics. The real world isn't a neat, tidy lab. It's messy and unpredictable. So for a robot to operate safely, it has to process a ton of data and make smart decisions in milliseconds. So, how on earth does it do that?
Well, think about it. If you try to use a traditional computer chip, a CPU, to process 360 degrees of vision data, it's like trying to drink from a fire hose. It just gets completely overloaded. The solution, it turns out, is high-performance video chips, or GPUs. They process tons of visual information in parallel, creating a kind of silicon spine that allows Atlas to see and reason at the exact same time.
Okay, so the spine gives it perception, the ability to see. The brain gives it cognition, the ability to think. And that brain is powered by something called a foundation model. Instead of coding for every single possible action, you train a massive AI on a universe of data. This gives the robot a general understanding of the world, so it can interpret a high-level command like organize those parts and actually figure out the steps all by itself.
And this is exactly why the partnership between Boston Dynamics and Google DeepMind is so powerful. You've got Boston Dynamics, who built the best robot body on the planet, and then you have DeepMind, building the most powerful AI brain. It's the perfect match to bring this whole vision to life.
The brain actually operates in two modes, which is pretty clever. For instant reactions, like stopping before it runs into a person, it uses a version of Gemini that runs right on the robot itself. But for more complex planning, it taps into the massive power of Gemini in the cloud. This dual system makes it both instantly reactive and a deep, strategic thinker.
All right, so we have the body, the spine, and the brain. Now, let's see how it all comes together in the real world. Because I have to stress, this isn't some far-off research project anymore. This is happening right now, on the factory floor. And it's happening at a massive scale. By 2028, Hyundai plans to produce 30,000 of these robots a year. This isn't some niche product. This is the beginning of mass production for humanoid workers.
And the deployment plan is super clear. Right now, the robots are being trained in a specialized facility. By 2028, they'll be working at Hyundai's Georgia plant, starting with organizing parts. Then, by 2030, they'll be tackling even more complex assembly tasks.
And these are real, valuable jobs. We're talking about handling materials on its own, sequencing parts, navigating a busy factory floor with people all around. This is so far beyond the choreographed demos of the past. This is about creating real economic value.
So when you take a step back and zoom out, you realize we're looking at more than just an advanced robot. We're witnessing the convergence of three powerful technologies, creating something entirely new.
You have the perfected body from Boston Dynamics. You have the processing spine,
powered by high-performance computing, and you have the general-purpose brain from Google DeepMind. The fusion of these three elements is what defines this revolution.
You know, this isn't a totally new idea. Way back in 2013, with that first shaky Atlas prototype, AI expert Gary Bradsky said we were seeing the emergence of a new species, Robo Sapiens. It sounded like science fiction back then, but now, over a decade later, that vision is becoming a reality.
We're moving from single-task machines to general-purpose, intelligent physical agents. This is the birth of embodied intelligence, or what you might call physical AI. These are robots that can learn, adapt, and work in environments that were built for people.
And that just leaves us with a final, fascinating question. For the first time ever, we've combined a truly capable body with a truly capable brain. The implications for manufacturing, for logistics, for our daily lives, they're profound. This is the start of a whole new chapter, and we're just beginning to write it. So I'll leave you with this. When you give a body a brain, what does it dream of next?